Okay, this is question 6 taken from A2 module 4 January 06 January 2006. So this is question 6. First of all, it says 2 point charges in a vacuum are separated by a distance r. The magnitude of the force between them is F. Sketch graphs to show how F depends on R. Well, what we know is that F depends on R as an inverse square relationship, so we should have a graph which looks something like that, and that is graph 1. The charges now have values plus 2 and plus 2q and minus 2q, therefore we're going to have a similar shaped curve, but it's going to be above that, and it should always be above that one all the way. And again, these should be asymptotic to the axis, not touching the axis at both points there. Okay. 2 charges minus q and plus q in a vacuum are a short distance apart as shown. So here's the diagram, minus q and plus q. X, y and z are points on the perpendicular bisector. Mark the directions of the electric fields at the points x, y and z. Well, this positive point put here is a positive point charge placed at y is going to be pushed by that one and pulled by that one, so overall it will go in that direction. If we take a look at x, and again if I'll just go out here to the side of x, this is x. X would be pushed by the plus q, okay, and it would be pulled by the minus q, which overall gives a field in that direction. So again, we have a field acting from right to left there. For z, and again for z, if we look at z, what's happening here is z is going to be pushed away by plus q, and it's going to be attracted by minus q, which again gives us an overall field or force acting in that direction. So all of those will be horizontally from right to left. Then it asks for us to say at which points x, y or z does the electric field strength have its largest value, and that largest value is obviously going to be at y. Why would that be? Well, because this is all of the force from q and all of the force from minus q and all of the force from plus q added together, whereas this is a component of it added and a component added down here at z. So obviously it will be largest at y. Uniform electric field is set up by applying a PD between two parallel metal plates. Sketch a graph to show how the field strength E between the plates depends on the inverse of the separation. Now, the equation that we use for working out the field strength for between two metal plates is E is equal to V over D. Therefore, E is proportional to 1 over D when V is a constant. Therefore, we're going to get a straight line through the origin. Figure 6.4 shows the arrangement of parallel plates described up above. The direction of the uniform field is marked on the sketch, so the field is acting up. Label the polarity of the plates. So remember, this is the direction that a positive charge would move, which means that this must be a positive at the bottom and a negative at the top in order for a field to be like so. And then finally, what's the strength of the electric field midway between the plates? We're given the strength is 7 times 10 to the 3 newtons per coulomb. Separation is 12 millimeters. Just be careful there, millimeters. Calculate the PD. So, well, I've just said that the equation is E is equal to V over D. Therefore, we can say 7 times 10 to the power of 3 is equal to V divided by, well, it's 12 millimeters. So that's we're looking for the field strength midway between the plates, but because it's a constant field all the way, we're just using 12 times 10 to the minus 3 there. Therefore, that means that V is equal to 7 times 10 to the power of 3 times 12 times 10 to the minus 3. Therefore, V is equal to, well, essentially that's 7 12s, which is equal to 84 volts. So we have 84 volts there. Now, just be careful here, okay? Why are we using 12? Well, that's because between parallel plates, okay, so it said this was minus up at the top, and this is plus down here. Between parallel plates, remember, we get a uniform field, so the field strength E is constant, equally spaced, parallel lines, uniform field, so it doesn't matter if it's halfway or a quarter. Now what does change between those is the voltage is different as you go across there, going from 0 up to 84 volts. But whenever you're doing that calculation there, you use the 12 times 10 to minus 3, because it's the field strength is equal to the voltage times the difference between the distance between the plates. Even if it's in the middle that you're looking for it, if it's at the middle, if it's anywhere there, the field strength will be constant throughout.